Hey there, Tony here from Cornerforge Studios. In today's devlog, I'll be going over the improvements I made in detecting Dagger special attacks and how I rebuilt the enemy damage and death systems using the Niagara Data Channels and the Niagara Neighborhood Grid3D system. This video is a bit delayed due to some of the issues I was having getting my damage system to work in Niagara. I finally have it working the way I want, but it took several iterations and an extra week to accomplish. I still have a little bit left to do, which is the focus of this week, along with implementing the last of the Dagger abilities, but let's start with the Dagger special attacks. The first thing I did to improve Dagger special attacks was to clean up the code by creating specific functions for both the backstab target and the death from above target, as well as commenting all the nodes and making it look better. And I also implemented a ray trace, which you can see here allows you to select specific targets and make it easier to choose who you want to attack. I added tags to the dagger, pistol, and sword abilities to prevent you from starting a new attack before the old one has ended. I did this by adding this weapon primary tag to the character when you're swinging, and then if you are swinging, it'll block this from happening again. And it's the same for all of them, so you can only have one active primary at a time for it to work correctly. Having the tags in place allowed me to set it up so that you could hold down the button to repeat the attack, and the character would go through the full attack animation instead of just repeatedly doing the very first part, which is a very nice addition. Here you can see that if I tap it, the character will attack once, but if I hold it, they'll continue to attack, but go through the entire animation to do so. And you can also go in and stab the character now, and they will die. The existing parkour system also uses gameplay tags and stores them locally on this parkour state variable. But the problem is that I need this actually replicated into the gameplay ability system so that if, let's say, you're hanging against a wall, you're not going to be able to attack, but there's no way for the ability system to know that you're hanging on the wall unless I push this into it. So what I ended up doing was I created this event dispatcher, which is essentially like calling a function, but anything listening to this will get this function call passed through. So it takes the player state, passes it through in here, and then anything listening will be aware of these changes. So after I set this up, I went into the character and listened to this event on the ability system. And essentially what I did is make some effects that would push whatever state changes happened into the ability system as well. As you can see here, I can still attack because I temporarily disabled the code that would add the tags to the ability system. And this is what was happening before. You could just attack even though you're on the wall. But if I re-enable pushing these tags into the system and save and compile, you'll see that now clicking the attack button and nothing's happening. One thing to note is that even though I'm clicking the button here and I can't attack, I actually do want it so that certain special attacks can still occur, so that if it detects someone like here that's close enough that you can do a death from above attack, I'll still be able to click on it when they're active and you'll jump off and attack them properly. So that's something I'll be working on this week as well. One of the other bugs that I ran into while I was doing these tests was this weird thing that came up where I would actually attach to an invisible surface, and I really didn't know what was going on. I thought originally that maybe it had to do with an empty collider or something that I had left on the stage that was causing a problem that didn't actually have a visual element, but what it turned out to be was these health bar widgets. I had not disabled the collision on them because they don't need colliders. I just forgot to do it, and yeah, it was a weird bug, and it took a while to figure out because I had to basically output everything I was getting attached to so I could figure out what it was, but yeah, it was very annoying. The last thing I did to improve the Dagger special attacks was add the ability to pass in custom data to the backstab or death from above ability. In this instance, I'm passing in a special target, which is essentially the backstab target if you have one, or the death from above target. This is set in the stance, so this is the same code that would check to see if you're actually pointing at one by doing a ray trace, and then if everything is good, then it'll set it as the special target. Then when you go to do an attack, it'll actually check, so this is the primary ability attack, it'll actually check if there is a special target. If it is, it'll actually do the backstab effect, or I haven't added it yet, but it could also potentially do the death from above effect. If there isn't a valid target, then it'll actually just do the standard primary ability. So if we go in and look at the game itself, you can see this happening. Just give it a second here. Oh, look at that. I'll have to fix that bug. Alright, so we'll see this happening by here. You can see I'm targeting them in the back. They're highlighted. Here they're not, so I'm just doing my regular base damage. But back here you'll see that it's showing the backstab because that's a different ability going through. I previously figured out how to make it so that the particles would spawn on two separate meshes by creating my own get mesh data scratch pad that would take in the spawn ratio, how this is the percentage of particles that I want to spawn on the head versus the rest of the body, so around 2/3 or a third, and the also would take in the skeletal mesh body and the static mesh head, which it pulls from the whatever it's attached to. So if this Niagara is attached to the guard, this will be the guard's head and body, and if it's the player, it'll be the player's head and body. So that information gets passed into here, and then we just do a random between 0 and 1, and if it's above a certain value, then it'll use the body, and if it's below a certain value, it'll use the head. And effectively what that does is just let me distribute things out. So I just played around with it a bit until I found a ratio that was nice, and it worked really well for me. In the previous death effect, I had it set up so that as the particles spawned in, they would eventually despawn due to the lifetime set on them. But in the new system, what I needed was a way for the particles to exist permanently with a maximum lifetime of basically indefinitely, and then have damage events come in and then just scale those particles up so that they're always persistent. And then at the very end, when the character actually died, it would sweep through and set the lifespans to destroy them the way the effect showed here. As you can see here, this new effect has the particles living endlessly, and I just scaled them in as needed to achieve this spreading damage effect. So the way that this hit effect works is when you have the pistol equipped and activate your primary, so this is just the primary ability on this stance, is it grabs the character that's activating it and looks at their scene component, which is essentially the camera facing out. It passes this into the ability because it'll need it to do some processing. So it tries to activate the ability. If that's successful, then it delivers the payload of data, which is the camera target. So inside the gameplay ability for the pistol, it'll go through, wait for that data to come in. So the first thing it does is just make sure you have the required resource to activate. Then it'll wait for this event data to come in because it needs it. It'll grab that look scene camera, do some math to project that out into the environment, and then do a line trace. And if it's successful, what it'll do is do an apply point damage to the target if it's a valid target. And then from there, what'll happen is the valid target, in this case it's the enemy, will be listening for this point damage and create a Niagara right data channel, and then populate it with the information from the specific hit location. I'll probably have some data pass in from the pistol as well to write out so it knows the damage type, the radius size, and things like that. And then this gets fed into the data channel system in Niagara for it to use inside here and create the effect that you saw. Now the effect that you saw that I'm showing you is actually the end result after 2 weeks of work. Where I was at this point was just having these particles distributed out, and I had it set up so that I had this wave effect with the particles spawning in and coming out by just using a modulus of the time to do that. So this is my starting point, and from here is where I slowly move towards the final result after a few issues that I'm going to be going over. One of the other issues I wanted to address with this system was that even though everything was distributed on the mesh as far as the points were concerned, I still found that after I did the alignment, there were still holes that were everywhere in the system because it wasn't spreading out evenly. I could actually address this by going in and increasing the number of particles, but the problem with that is that it would be much less performant, and there'd be a lot of alignments that had multiple
pixels in the same area, so there'd be like 20 here or 30 there because they're all lined up and bunched up in the same place. After looking around in the forums, I found that there was a setting that could easily be changed to fix this issue. All you had to do was go onto the skeletal asset and go down and find the support uniformly distributed sampling and check that. And what that would do is now when you went in here, it would actually distribute it much more evenly. And you would see that you could actually reduce this down to a much lower value and still get a good even distribution without any holes. There is still the occasional one, but with the glowing and other effects, it actually works out to look pretty good. One of the other issues I ran into while I was testing was that when I did my shot, it would do a ray trace, but it was actually hitting the capsule collider, not the body itself. And when I went in and looked, like I had originally set it up so that I had a channel, trace by channel, that used the shootable channel, which the capsule was set to ignore and the mesh was set to hit, but for whatever reason it wasn't ignoring it, it was hitting it. So after playing around with it a bit, I actually ended up making my own custom object channel, shootable objects. Then I changed my ray trace detection from the trace by channel to trace for objects, and then made an array of shootable objects, and that actually corrected it for me. So there's been a few things like this where I had to go in and just make little tweaks to get things to work the way that I want them to work. To create the original death effect that would spread across the body from the original damage point that killed them, I used the Niagara 3D, Neighborhood Grid 3D system. I ran into issues though when I tried to move the Neighborhood Grid 3D from being initialized in the emitter namespace to being initialized in the system namespace so that every emitter could see it. I needed to do this because in the design that I originally had, I had one emitter that would show the body and the head. It would make the those cubed pixels and align them, and then the other one, the intention was that when the character got shot, it would spawn a burst of particles at that shot location, and then those would interact with the Neighborhood Grid 3D system as well, so that they could communicate, and I could transfer that data onto the character and then have those particles spawn away afterwards. As you can see here, I actually had it all working correctly, where I could shoot the character and the burst of particles would appear around where I wanted the damage to be, but there was some issues with this that made it so that I couldn't ultimately use this solution. The problem that I ran into was that when I defined the Neighborhood Grid 3D system in the system namespace over here, the emitter could see it and I could try to write and read values from it, but when you actually went in and looked at the debug information itself and did a capture, even though I set the number of cells to 256 for X, Y, and Z, it would come out as 100. And this is actually, after a bunch of testing, I found that this is actually an indicator that it wasn't initialized correctly and that you can't use it. And I actually had an error, which I'm going to bring up on the screen here, that only showed in the editor when I closed out of Unreal and reopened it. But basically it said that I was having issues with the size of the total size of the array that was being used, but also there was other issues with it being in the system namespace. So ultimately what I ended up having to do was to merge the spawn effect into the emitter and move the Neighborhood Grid 3D system into the emitter as well, so that they were both available. Well, they were both here. All the particles were in the same emitter and were able to use the same Neighborhood Grid 3D system. I did a number of things to try to get it to work using the system namespace, but in the end I just couldn't get it to work, and I really couldn't understand why it wouldn't. I've seen other examples where it did in the past, so what I ended up doing was deciding to change the direction I went to essentially squeeze all the emitters together into one with the Neighborhood Grid 3D system, so I wouldn't have to rely on it being an external system namespace. It could all be in the emitter namespace. I'd like to tell you that after squeezing everything together into one emitter, everything just worked out perfectly, but there was a number of other issues that I had to deal with. But before we jump into those, just another quick note on this. If you see 100, 100, 100 for the size after outputting it, one of the other reasons could be that you're making the array size too big. It wasn't the issue in this case, but if you go 256, 256, 256 times 8, That's a set number, and I'll show the error on the screen here that I got. If it's higher than that number, then it'll basically knock it back down to defaults. It won't tell you anywhere, and I think I have a reaction to my my feelings on that. Yeah, that shows it pretty good. But if you do see that, then you just have to make sure that you change your array sizes so that you don't get any more than that maximum number. If you're curious on how to get these numbers, what you have to do is just go in and create a custom scratch pad. In here I have it doing a number of things for cleaning up, but it's just this code right here where you can get you define the number of cells, and then you call this grid function get number of cells, and then input these values, it'll output them, and then you just make it an output. So the grid I've inputted here from my Neighborhood Grid3D for the emitter, and then this out is just the out here that goes to values I set on the particle itself, so that when I do the debug outs I can just see what those values are. The ultimate goal is to have the damage come in through the Niagara Data Channels so that the particles are aware of new damage and are able to respond and make the wave effect accordingly. So this is the Niagara Data Channel. It writes position, radius, the damage type, duration, some other information used that I'll explain later. But the two big parts are the position where the damage is and the radius. So I have a crude drawing here that kind of represents what the player might be. And at all times there's always there's points all around the player or the character that I've shown you before that get put on the various triangles, and then what happens is they get pulled off of here and aligned to the closest grid element, and these are cubes that represent the same spacing. So effectively what I get is this cube pixelated version of the player around them, made out of all these little boxes. So that's always happening, and that happens prior to any of the damage stuff being figured out. So there's always this pixelated mesh following the player around. So when new damage comes in to hit the player, then there's going to be a point inside here that the player that will be passed in through this data channel. So it'll be the position here where it got hit. And then from there, the radius will dictate how far away this effect should take place. So that's configured on the gun, so different ones will have different spread effects. So when that happens, when a new data channel instance comes in, then there's essentially a list of, like, it gets added to a list of all the points of damage that get done. So, you know, if you got shot multiple times, or if it's a shotgun or something, there'd be more in this list. But for now, there's just the one in this example. So we have this one coming in, and then it has this point where it got hit, and then this radius. So what happens is, after it aligns everything, every particle will go through this list, and in this case there's one. So let's say it's this particle, and it'll say, oh, I am here, and you know, I'm within the distance, within the radius, so I'm part of this damage. So this particle itself also has its own list of things that are affecting it, and there's an array of 10 things that could be affecting it. So it adds itself to the array in the right index, and then all these will go along and correspondingly be added to this because they're part of the radius. And then anything outside of it will just ignore that when it goes through, because it'll see it's outside the radius, so it'll do nothing. So subsequently, after that happens, what happens after the damage gets added is there's another update that occurs that goes through this list, and for every one that's active, it'll actually calculate the intensity for it to make this specific pixel get bigger or smaller as needed. So that's kind of how that works. So you can essentially have 10 different slots of damage, and then if a damage entry comes in, it'll add it to the next part in the array, and it just loops around and around. So if you have more than 10, it'll just keep going around and around with the indexes. And the way that I do that is I just have like an active flag, and I also have the time offset. So the way that I know and how I make the effect kind of ripple out is that the start times are different from the center going out to the full radius. As you can see here, this is my whiteboard that I used to figure out a lot of this stuff, and there was a lot that was involved with getting all this working correctly. But in relation to just getting a nice pattern to wave out from the center of that damage that I showed you from there. Effectively what I wanted to do is have a value that went from 0 all the way up to 1 and then back down to 0 again in a nice curve. And it wasn't that hard to essentially have a normalized value, so essentially a number that went from 0 to 1, by taking the start time and then wherever the current time was, I just minus the current time, or sorry, minus current time from the start and divided by duration, and that essentially just gives you a 0 to 1 sometime in the scale of the full duration. And then if you plug this into a curve, which you can have in the Niagara system, you can set up these curves to reference. You'll input your normalized value, which would be from 0 to 1, and what it'll output is this height here. So at 0 it's going to be nothing, and then it'll slowly go up, then it'll stay at 1 for a while, then it'll slowly come back down to 0 again. So effectively what I get is I get this nice curve. But if I did that for all the ones in the pixels, if every little pixel or cell in here did the same thing, then they would all come up, so it would all glow at the same time, then they'd all disappear at the same time. So to fix that, what I realized I had to do is, to get two different offsets, I would actually have to just offset the time. So these would be like, 3 different waves of different timings, and if I wanted that effect to happen, then essentially all you have to do is offset them, so that when this one's here, just at the start of its curve, this one is actually still at 0, and then when this one's almost at its full peak, this one is just starting. And then effectively what that does is, by offsetting it the further you get away, is that the centers actually start and they're more solid at the center, and then it slowly works its way out, so that at the beginning this one's like this, this one's like this, this one's like this, and then later, as this one's coming down, this one's still going up and coming up, right, because it's just waving through. So there's a lot more intricacy that goes into it, but that's kind of the general gist of how I got all this to work correctly inside and underneath the hood for the code for updating. So what I just described to you was the end solution that I eventually reached. There was 2 other main issues that I ran into that led me to that, that I had to kind of evolve my thinking on for it to work correctly. So as I described before, like, damage would come in and then hit one of these cells and then spread out, but my original design had it so that when damage came in, it would spawn a group of particles, and then my intent was to have those particles communicate using Neighborhood Grid3D to the ones underneath, that they were part of the damage, and that's the way that they would know which one to use. But what I was finding was that when I'd go in and shoot the character with the various particle effects, they would spawn and they would get aligned and everything would work correctly. But the problem that I ran into was that when I tried to push that data over to the grid cells, like these cells that followed the actual character, they wouldn't work. So you can see here it's blue in this spot down here. So what I was doing was I was actually coloring the spot that got hit blue wherever it got hit, to show that the data got transferred correctly. But in practice, when looking at the debug log and the results, blue dots would appear everywhere throughout the character. So I really couldn't figure out why that was happening. There really wasn't any reason for it to happen. I'm thinking it might have had to do with the index ordering, because you feed it in the execution index, but or maybe it was because it shows as a 3-dimensional array, but in practice it's actually just one long array that gets indexed differently. So I was thinking maybe I was overrunning it, so I removed one from the end count and nothing seemed to work. So what I ended up doing was changing over to another method, using arrays, where I would add damage to that array of new damage coming in, and then the particles had a number of arrays as well, that damage would get transferred to, so that I could do all the timing that I talked about with the start time, duration. That was all recorded in arrays on the particle. But that also ran into some problems. The problem that I ran into when I wanted to use arrays inside the particle itself, as you can see I defined here, I called them damage table and then underscore for the various things I had. So I wanted 10 entries for the active, whether it was active or not, specific curves for each one. I felt that would give me a lot of flexibility so that each pixel or particle could have its own set of values that dictated how it did its waves. So no matter how much damage or whatever different types of damage, they could all do their own thing and not really interact with each other or not worry about anything else. They could just do what was told to them when they were initially set up. But the problem that I ran into was that these arrays didn't actually work the way that I thought. So I added these on. These are just float array, vector array. So instead of just adding a specific float, I'd add a float array. And then inside the particle spawn, I'd actually initialize these to be fixed amounts, so they're 10 elements. And then when the damage came in, I would transfer the data over from the damage that came in, like the one hit entry, to whatever the corresponding index was at the time, so that it could basically take the sum of these and use that as its intensity. But what I actually found in practice was after I added the intensity, as you can see here, the active flag would be set. So this is right after I input some fake data into it. I did a capture and it's set active, and you can see everything is active. But the problem is it's not actually doing the spot that I wanted to, because I actually have a section on the chest here and a radius, but it's actually taking effect on everything. Everything has the active flag. And then if you continue on, eventually all of them will turn off at the same time too, and they'll be deactivated instead of just everything within the radius. So I did a bunch of work to try to figure out why it was doing this, and spent a bunch of time in the debug code here just outputting whatever I could to try to get under the hood and see what was happening. And from what I found out, it looked like all of these float arrays, or all these arrays in general, were all being updated at the same time, even though I had an if condition. I don't know if it was because of the compiler or the way that it shook out in the end, but whenever I tried to make a change to a specific array element, it would actually do it to all of them. So they basically acted like static variables that all the particles could communicate with, which was very bizarre, and it's actually not documented. I think I have another reference video of how I felt about that when I figured that out. Yeah, that's pretty much sums it up. So after finding this out, I realized that I couldn't use these arrays the way I had planned, and looking back on it, like having the particle burst system, that was to try to work within the systems, because I wasn't aware of how the array system works on the emitter, so I didn't know I could have a list there that all the particles could talk to, and there was all these other things that I had to kind of discover as I went along. But ultimately what I ended up doing was taking these away and replacing them with just static list set of the various things. So I made a 0 for active and start. So these aren't an array, they're just 10 separate individual variables that I could alter. And then once I changed it to this system, everything started to line up and work perfectly. So I had the array that received the data channel entry. From there, every particle would see if there's anything in that array, and if it was, check the radius like I showed before. It's not there anymore, but I showed you before. And then once that was added to the specific slot, depending on if the damage was in the radius, then it would go through every iteration and check all of these slots, and if any of them were active, it would put that value into the intensity and have it add as part of the total, which gave the scale for that one specific pixel. And that gave me all the flexibility I needed to essentially complete it and get everything working the way that I needed. I do want to say that part of the issues that I ran into were due to some of the ambiguity with the way that the system works with the Niagara. For instance, if I got to do more research, but if these are indeed not these ones, but these ones here, if these float arrays are technically static, there should be something in here that is an indicator of that static nature, because you can actually add static bools and things like that. and they are specifically indicated that that's the case, but they really should have something that indicates if you're going to make an array that it will get knocked down to being static due to the limitation of the system. So that's a way that just the user experience can help. There's also a lot of little things with the way that Niagara works with these input lines going out this way to the end and then having these little offshoots. Like normally in a blueprint you'd have a sequence. So they don't really follow the regular blueprint patterns in programming, and they also don't really follow a lot of the regular standard just coding practices that you'd have in C++ or other things. So it's not necessarily a problem if you have a different convention, but you should really clearly communicate that either through tags or visual cues or warnings, or just having a different language as syntax. So maybe use a different color or something, something to indicate what's happening here, so that it's translated to the user better, or at least translated that this is a different experience than a regular blueprint. So you can think about it in the proper way and start to get those things visualized in the proper way. So those are just some closing thoughts on the Niagara system. I'm pretty much wrapped up with a lot of the more complicated bits. I do still have to do the death sweep, but that's pretty straightforward. It's just manipulating the intensity that overrides whatever the damage is as it sweeps through. It works similar to the system I had before. I just have to tweak that and put it in here. So once I'm done this, I'll be moving on to more simpler effects, just like a little splatter here and there, a little fountain, stuff that's extremely simple to do. But that's kind of the course I've taken over the last couple weeks trying to get this working. And honestly, I probably should have thinking back on it, like it's been a lot of series of little things that have drawn me in further, where I think I'm on the edge of fixing it, I fix it, and then it's broken, and I had to keep doing that. So that stretched over 2 weeks of me constantly changing, looking in the system, figuring out how it works, redesigning my stuff. Like if I knew how all this worked from the get-go, I could have designed the system that I originally fell upon, which is actually a pretty optimal system. But because I had to do a lot of learning on how the system works, I didn't start there. And in retrospect, it probably would have been better to design around the problem, because if you're doing an indie game and running into these kind of issues that take 2 weeks, unless it's a really core issue, you should really try to find a simpler way to do it and move on to other features. For this specific one, like the death and damage effect are really part of the whole feeling of the game and the immersiveness of it all. So I didn't really mind spending a bit more time on it. It did go a little longer than I expected, but I am really happy with the results, and it's actually more performant than any of my previous ones that I've created, even the one that just activated and got destroyed. So it's a lot more efficient, and it covers almost all the bases I'm going to need. And then once I'm done this, it's done. I can just set it aside and maybe tweak, values here and there, a little bit of polish, but the bulk of the hard work's done. It's just little things from this point on. This video took me a while to get out due to me being laser focused on fixing this problem. As I said before, my priority is always to get the game out, so if I do run into an issue that is particularly challenging, I will be focusing on that until it gets done. The good news is that this is the only real system that has this level of complexity in an area that I'm not super familiar with, so all the other stuff going forward should be much quicker, and it's still going to take time, but it's definitely stuff that's within my wheelhouse, so I shouldn't have any more delays. That being said, the next video will be coming out on Monday. That's my new day that I'll be releasing my videos, so I don't anticipate any problems with those coming out going forward.
That's all for today. Be sure to like and subscribe or join our newsletter using the link below. Thanks for watching, and we'll see you next time.